Hey engineers, welcome back. So for this video, we are going to go over the challenges in circuit 1A. Notice we do have two challenges and these will be the ones we will be solving. And to make sure you are ready to go, you need to make sure that your wiring is already set up, your circuit diagram is already wired up, you have your two jumper wires, your resistor, and your LED. In addition to that, you already need to have your code uploaded. So you should be using CodeBender, or you can already use Arduino. My Arduino is showing that I have 31 lines of code being used, while CodeBender has 31 lines of code being used as well. So just notice this so that whenever I make changes on Arduino, you do the same changes on CodeBender or Arduino IDE, whatever it is that you're using. So in this situation, we first need to identify what our challenge is asking us to do. Persistence of vision. Computer screens, movies, and lights in your house all flicker so quickly that they appear to be on all of the time, but are actually blinking faster than the human eye can detect. See how much you can decrease the delay in your program before the light appears to be on all the time but is still blinking. So notice they did tell us what to change, so they're telling us to work with the delay. So let's go ahead and change the delay. So I'm going to change this to 100 and we'll see what happens. I'm going to click upload. So now my TX and RX buttons are blinking so fast that was showing that there was communication between my computer and my Redboard. So now as we notice, my light turns on very quickly and it stays on for a little bit amount of time. However, it stays off for a longer amount of time. Now let's change our low to 100 and see what happens. So remember, these delays relate to the amount of time that a function is being used for. So in this situation, my light or my pin 13 is being provided with electricity for 100 milliseconds. And then it was off for 1000 milliseconds, but in this situation, we changed it to our low to 100. So now our light flickers faster because it's staying on and off for a shorter amount of time. So that's pretty much how we solved this challenge. So challenge number 2, Morse code. Try changing the delays and adding more digital write commands to make your program blink a message in Morse code. In this situation, we're going to copy and paste digital write high and digital write low several times so that we can create a message using Morse code. We're going to use Morse code by blinking lights at different speeds so we can communicate a message. In this situation, I'm going to communicate the message of cat using the letters C, A, T. So in this situation, every line and dot is a different blink. So let's start off with the letter C. Keep in mind, for this code, a line is going to represent 1000 milliseconds and a dot is going to represent 500 milliseconds. All right, and let's just write that down so that we don't forget. So I'm going to put // to add a comment. And I'm going to write out that a dash is equal to a 1000 milliseconds. While a dot is equal to 500 milliseconds. Our word is going to be cat and our first letter is going to be C. So C, if we go back to Morse code, is dash dot dash dot. So this is going to be really easy once we get the pattern down. Dash dot dash dot. And now I'm going to add a separate line because I want to see what A is going to be. So A is going to be /, and then T is a dash. So remember, a dash is 1000, so I'm going to change this to 1000. So my LED is going to stay on for 1 whole second, and anytime that my LED is off, I'm going to keep it off for half a second. So now the next one is a dot, so I'm highlighting lines 25 through 28. And I paste it, but keep in mind, my next letter has a dot. So I'm going to change my high to 500. And notice this is repeating, so I'm going to copy all of this and paste it below. And that's my letter C. So remember, I can't use CodeBender, but once you're done typing this up, hit run on Arduino to upload your code. Verify my code, make sure it works. Everything's written correctly. So my code has been verified Now we're going to upload. All right, so now I'm going to click the reset button so we can actually count out our blinks. So I'm going to hit reset to start the blinking pattern. So we should see a long blink first. So let's try it out. 1 second blink, half a second, 1, half a second. All right, let's move on to our next letter. A is going to be, so short blink and a long blink. So I'm going to just copy this portion right here because that's my short blink with a long blink. And I'm going to paste that down there. And that's all we need for letter A. And for letter T, all we need is a long blink. So let's go ahead and copy and paste that. So I have my letter C, 4 blinks, high, low, high, low, high, low, high, low. 2 blinks for A, high, low, and then 1 blink for T. So let's go ahead and upload. So at this point, I have a problem. Okay, we cannot differentiate between letter C, letter A, and a letter T. Well, we can, but it might be difficult. So what we need to do is add a pause between the letters, and then at the end of T, we're going to add a longer pause to make sure we know that there's a different word. All of my delays are the same. So at the end of each letter, so letter C, I'm going to add a 2000 millisecond delay to know that that letter is done. Same thing for CA. T will have a delay of 4000 to know that our word is finished. So let's see how this looks. So I'm going to reset. So we should see a total of 8 blinks for this word. 1, 2, 3, 4. That's our cat. Long pause, 2000. 1, 2. Long pause. And a 4-second delay for low, which signifies that our word is over. That's pretty much cat in Morse code. So try creating your own message.